Okay, this video is going to talk about the majority of the topics that we covered in quarter one and how they relate to one another and how to best tackle them when you look at them as a collective unit. So this first slide here, we're going to talk about solving equations. So the first thing you have to do is understand what variable or piece you're trying to isolate, and two, what type of equation it is so you know how to work within it. So we have three different types of equations here. The first one, absolute value. And I can see that here by recognizing this part right here. So I need to isolate this element here. And knowing with absolute value, you're going to have two solutions, negative and positive side of the scenario. So I need to get that by itself. So I need to undo what I have. So I'm going to add 4 to this side, add 4 to this side here, and we get 3. Then the absolute value doesn't change, and then less than 9. Next, we're going to divide by 3, and we get the absolute value by itself. Okay, so now we're at this point in time, I'm going to switch it into a positive and a negative side. So when I do that, I'm going to have x plus 2 is less than 3. And then over here, I'm going to have x plus 2 and negative 3. Now notice when I do this, I need to switch the sign. So I'm going to put a big star there saying we got to switch the sign because you introduced a negative. And you solve them as two independent pieces. So move the 2 over and x is less than 1. And here move the 2 over and x is greater than negative 5. So if you put on a number line, so here's 0, we're going to have 1, and we're going to have negative 5 over here, and we're going to have less than 1, and notice open circle, and it's connected because it's less than 1 and greater than negative 5. So this is like an AND statement. Now remember, if we do an OR, I'll just make a little note over here. An OR statement would be repelling sets of answers. Okay. Now the next one, literal equations. This one we're solving for a variable in terms of other variables. So let's say we want to solve for in terms of r. So the first thing I'm going to do is isolate where's r at right there. So I need to undo this. So the first thing I'm going to do is subtract ab from both sides. And again, you treat the letters just like numbers. So when I see this, I'm going to have g minus ab is equal to 1/2 r times t. Now the next thing I'm going to do is multiply both sides by 2. And again, do it with parentheses because we have to get rid of everything. So notice the 2's cancel. And we have r2 on this side. And we're going to have simply, 2. And I'm going to leave it in parentheses. G minus AB. And the last thing to do here is get the t out of here. Now, so I see r times t, so how to do that? You divide by t to both sides. And scoot it over here a little bit. So we're going to have r is simply 2 times g minus ab, and then all over t. Now again, you could distribute here and so forth, but the important thing is to get r by itself. So I'm treating the letters just like numbers. That's the key thing here. Now this, when I see this, it looks a lot like this type equation. And these are the type of connections I want you to see. So the x is inside the parentheses, which is squared. So before I do anything, I need to get this by itself. So the first thing I'm going to do is move the 3 over. So I have 2/3, and then, I refer to this like smiley face, so get this part by itself. And we get 2 over here. And then we're going to multiply by the reciprocal, both sides. And notice those cancel out, these cancel out, and we have x plus 3 quantity squared is equal to 3. Now, what we're going to do, I'll switch colors here, is we're going to take the square root of both sides, and don't ever forget that plus minus, because now we're solving, and there's two solutions here. So we have x plus 3 is equal to plus or minus the square root of 3. And again, now we can get the x by itself because we're now inside those parentheses. And we subtract 3, and that goes to the other side. And you have to understand, this is two answers. Okay. Notice we had two answers over here, two answer sets there. Here, one answer, okay, because there was no squared term or absolute value to worry about. And here we have two answers. So here's all solving, but notice we have different scenarios. So those are three main topics we have to cover. So look at solving quadratics. So these are all x squared. So all in all, what you want to do is first set it equal to 0. That's a huge thing to do. So I'm going to move everything over to this side. And again, to do that, I want the x squared to be positive, helps us out. So now that I set it equal to 0, I can look, okay, what can I factor here? Well, I can take a 2 and an x out of the scenario. Okay, and when I do that, you have 2x minus 1. Okay, I just factored that out. Now here's zero product law. A times B equals 0. So you set the first part equal to 0, the second part equals 0, and x can equal 0 over here, and then x can equal to positive 1 divided by 2. So again, you're moving that 1 over and divide by 2. So maybe I'll just show that down here. So you have 2x minus 1 equals 0. You have 2x is equal to 1. And then finally, x is equal to 1/2. Okay, so there are your two answers there. Okay, we did that by first setting equals 0. Now, excuse me, this one you notice is already set to 0. So I'm going to look first, can I factor anything out? So I guess the first thing we can do here is, we could factor out a 2, but and that would probably help us out. But I'm going to show by completing the square. So I'm going to go ahead and move the 10 to the other side. And now I'm going to factor just out a 2. Okay, I want to do that because I want to show how to factor out this 2. And when I do that, notice that changes to a 4. And we add a blank. Now, since I'm solving, that's why I can move it to the other side. I know when we talk about graph, we want to keep on the same side, but that's what we have here. So this step here, notice now we take the 4, we cut it in half, and then we square it, and we put a 4 there. So that's 2 squared. Now we have a 4, but we have 2 of them, so we've really added 8 to this side, so I want to add 8 to this side. So now we have negative 10 plus 8, and we have negative 2. Next thing is I'm going to divide by 2 on both sides, so I'll just show that real quick. And we have simply x minus 2, quantity squared, is equal to negative 1. And next, take the square root, just like we did on the slide before. Now notice, square root of negative 1 plus minus. So we have x minus 2 is equal to plus minus I. And that's the definition of I right there, square root of negative 1. Last step, x is equal to 2 plus or minus I. Notice I moved the 2 over. And notice there's that a plus bi form. We'll see this at the end of the video dealing with I. But now we can solve for imaginary solutions. Another way for problems like this is we could always use a quadratic formula. Okay, so that's another foolproof plan to work for. Now factoring. So again, I want to go back to this. I want to set it equal to 0. So I'm going to move everything to the same side of the equation. Okay, and the key thing here is, we can use split middle term and so forth, but I think a lot of people just like to set up their parentheses and say, okay, let's try to break this down and see what we can do. So here we can put in a 3x and an x. And notice we can't really break that, but we have to think, what are the factors of 8? We could do 1 and 8, or we can do 2 and 4. Okay, so I'm going to think, okay, how can I get to 14? Okay, now if I did 1 and 8, 8 times 3 would be 24, so way short, or 3 times 1, way too low. So I'm going to go with 2 and 4. So how's the best way to get to 14? Well, 3 times 4 would be 12, and then I need 2 more to get to 14, and there we go. They're both same sign, both positive, so I'm going to fill in my 2 signs there. And notice we can check it out. So here's the 12, and there's the 2, altogether 14. So set the first half equal to 0, 3x plus 2 is equal to 0, and then obviously x plus 4 is equal to 0. Zero product law, just like we did over here with the factoring. And simply x is equal to negative 2/3, and x is equal to negative 4. Okay, so different ways to solve quadratic equations here. But again, trying to pick the method that fits the problem the best. Okay, writing equations of lines. So all of these, the key to all of these is I'm going to really emphasize here is if you have an m, a slope, and some sort of starting point, then you can go ahead and do anything you want with equations of lines. Okay, so here we have, let's write an equation of a line that goes through both these points. So the first thing I'm going to do is I want to find a slope. So to find a slope is simply y's over x's. So I'm going to take 5 minus negative 7 and put that over negative 4 minus 12. So here we have positive 12 over negative 16. And then I want to reduce, obviously, so I'm going to take out what I need, 3/4 negative. Okay. Now, I'm going to go ahead and now that I have a slope, I need a starting point. Now, a starting point can simply be point slope form. So we have x and y. So I'm going to pick this point right here and plug it in. So I'm going to have y minus, and then I'm going to put my slope over here, and I'm going to do x minus. And all I'm going to do is plug in the point. So the y value is 5, the x value is negative 4, and since it's negative, I'm going to make it a positive 4, so it's the signs. Okay. Excuse me. So that's point slope form. Now again, if I want to put into y equals mx plus b, that's simply solving for y. So I'm going to move the 5 to the other side, and we have negative 3/4 x and plus 4. So that's still inside the parentheses for right now. And then we just put plus 5 at the end. We just move it to the other side. Now I'm going to distribute. So we have negative 3/4 x. Okay. And notice if I distribute 3/4 times 4, the 4's cancel out. We get negative 3 plus 5. And now we can finally get our b of y is equal to negative 3/4 x plus 2. Okay. So here we have a starting point of 0, 2. Here we had a starting point of negative 4, 5. Okay. So a lot of times you can keep it in this form, and sometimes they'll ask you to put it into a graphing form, and you could do that. And we'll see another way to graph this in a little bit. But there's two ways to do that right there. Now, rate of change, that's the slope part. So let's kind of see it as a word problem. With the population of Smallville grew from 2,000 and change to 10,000 and change from 2002 to 2008, what do you do? So what I like to do is start with a label. So I'm going to do population, or the number of people over the year. Okay. So I'm going to start with write out ordered pairs, just like we did over here. So the first ordered pair is in 2002. There was 2,345 people. And in 2008, there was 10,356. Okay, so just now I've translated it to a problem just like this. And to get the slope, you put the y's on top. Now I'm going to take the new minus the old. So I'm going to put, a lot of people like that new minus old is a good kind of a way to recognize that. And that way we get a positive denominator. So 10,000 minus the 2,000 number. And then obviously the 2008 comes first, minus the 2002. And again, that's our rate of change. Okay. So key is recognize it that the 2 points and treat it like a problem like we just did over here. Okay, parallel and perpendicular. So remember, if two lines are parallel, then you're going to have the same slope. Okay. And if two lines are perpendicular, then you're going to have the negative reciprocal slope. Okay, I'm just going to abbreviate there. So let's take a look here. It has to go through this point and perpendicular to this. So the first thing I'm going to do here is I want to figure out what the slope is. So I'm going to move the x to the other side. So I'm going to have negative 2y equals negative x minus 4. Then I'm going to divide by negative 2. So y is equal to 1/2 x plus 2. Okay, so I'm just, figuring out what the slope is. And I do that by solving for y. So now I'm going to put it into point slope form. So I'm going to do y minus, now look at my new point. So I'm going to do plus 6, do the opposite of that. And then I want perpendicular to this. So I'm going to go to negative reciprocal. So that'd be negative 2. Okay, as I take 1/2 and I flip it and negate it. And then I simply say x minus 2 for right there. So there's my point slope there. Okay. Now, notice here is standard form. So I'm going to show you how do we take this and put it to standard form. So I'll do it in a different color. So this is point slope form, which is totally acceptable. But again, sometimes answers, you need to put them into a different form. So I want to get all the x's and y's on this side and all the numbers over there. So the first thing I'm going to do is distribute these parentheses here. So we get negative 2x plus 4. Okay. And then the next thing is I'm going to move the x's over here. So those go over there. So I'm going to have 2x plus y. Now notice I'm going to move the 6 over and put all the numbers there. And finally, we just clean it up and add those last two together, and we get -2. So that would be standard form. AX plus BY equals C. Okay, X and Y on this side, numbers on this side. So that's standard form right there. Standard form, point slope form, finding slope, point slope over here, and slope intercept y equals mx plus b there. Okay. Okay, evaluating expressions. So I do a slide here because we understand function notation and how to evaluate. So simply over here, all we're looking at is, okay, if I give you an x and give you a y, can I plug it in here? And again, I think it's important to show this because these are inputs, and then we got to understand how these work because this tailors into a lot of things that we do later on. So I write it like this. This is how I see it. I see 3 times input minus 5 times input squared. And then simply, I just plug in my values, and I do it like this way. And the reason why is because I don't want to lose sight of this. And now order of operations says, well, that's 9, and then minus 5. Now I'm going to do this part 2 first. -2 squared is +4. So now we have 9 minus 20, and we're going to have -11. Okay, so that is the evaluation of that statement there. So it's good to show order operations, understand how to do that. Now, in a piecewise function over here, if I say, okay, let's let's evaluate the input of, let's just pick something simple, 1. Okay, and what is that? So first we have to say, where does 1 belong? Which domain? Is 1 less than 4 or bigger than 4? So clearly, it's going to be that one there. So we're going to plug it into only the first equation, the first piece there. So we're going to have 3 input of 1 minus 3, and that's going to equal 3 minus 3, which is 0. Well, look how ironic that is. So this is how you'd write it. The function of 1 has an output of 0. Okay, so if I wrote it as an ordered pair, it'd be 1 comma 0, and so forth. Now, let's say we went ahead and we said, okay, what's the function of 4? We want to input 4, so we have to look, where does 4 belong? Is 4 less than 4, or is 4 equal to or greater than 4? Well, clearly it's going to be this one. So then we plug it in this equation. So I'm going to put input squared plus 4, and we're going to plug in, obviously, 4 right here, and we're going to get 16 plus 4, which is obviously 20. And the function of 4 has an output of 20. So again, that's how we want to see that, and that's what that notation means. So we need to understand what this notation means, how to translate it, and we can see the same thing here. Okay, and again, it's always input, output. You input x's and you output y. So we typically have seen this in this fashion. We plug in x, you get out a y. But really, this is how we have to think about it now. Input x's and the output is the f of x right there. All right, let's talk about graphing. So in all these scenarios, these are lines. Okay, so it's all x to the first power. And here we have an inequality. Okay, so first we're going to have a starting point of 4. So let's get the color red. So I'm going to go up to 4. There's my starting point. So again, I need a slope and a starting point. So I'm going to put, we need an m and then a starting point. So I'm just going to abbreviate. And then our slope is 3. So we're going to go up 3 over 1, up 3 over 1, and then and so on and so on. And I'm just going to put some guide points in. Now notice, since it is an inequality, I'm going to dash my line because that line is not included. And then the last thing you want to do is do a test point. So if we can test a point 0, 0, which is always an easy one to do, then we can plug 0 and 0 in. So plug in 0 is less than 3 times input 0 plus 4. Is 0 less than 4? Well, yes it is. So then the point 0, 0 right there is included in the solution set. So I'm going to shade on the same side as that point. So I'm just going to shade this side in. And again, the dashed line's not included, but we can kind of see what we have here. Whoops. And we simply just shade in the side right here and show the shaded region right there. Okay, so there we go. Okay. Now let's go ahead and look at the second example. This is in standard form. Notice ax plus by equals c. Okay. Now here we can do, solve for y and graph like we did over here, or we can do intercepts. So it's like the cover-up method. So we're going to say, okay, let's solve for x and let's solve for y. So if I plug 0 into this equation, so put 0 in for y, that disappears. And 2x is equal to 12, so therefore x is equal to 6. Now, let's take 0, and that's now for x. So I'm going to cover up, put 0 in for x, so that disappears. 2 times 0 is nothing. And 3y is equal to 12. So now we can simply say that y has to be equal to 4 in this case. Okay, so we're basically getting two different points based on this equation by simply plugging in 0. So now let's go ahead and graph those 2 points, 6, 0, which is right about here, and 0, 4, which is right about here. And now we have 2 points. We can simply draw a line and put arrows on it. Oops, excuse me. And put arrows on the line so we can see that goes forever. I probably should do that over here as well. Okay, and there we go. Okay, that wasn't the best straightest line, but good enough. Now, it's going back to point slope form. You don't always have to convert it to this form or this form to graph. You need a slope and a starting point. So let's look at the starting point right here. So the starting point here is 2, 4. If that's point slope form, I'm looking at that and that. So I'm going to start at 2, 4. So over 2, up 4, and there's my starting point. And then from there, the whole line has a slope of 1/2. So I simply go, up 1 over 2, up 1 over 2, and so forth. And now, instead of my starting point being on the y-axis, it's just wherever it is on the line. Okay, so use the information given to you, and it's a good way to use the starting point of 2, 4. Okay, so to show you that no matter what form it's in, you can, as long as you got some data and a slope, you're good to go. All right, so here's more graphing examples, okay? And notice over here, we're going to have 2-point slope form. So in this slide, I want to show you how all the graphing that we've done are all related. So notice I have the same number sets here. This equation is absolute value. 2 times the absolute value of x minus 2 minus 3. And here we have a quadratic, 2 times x minus 2 quantity squared minus 3, okay? And then, this one's going to be the same thing over here. So they all have the same points, and we have to look at them all the same way. These are all in vertex form, showing a starting point and how we go from there. So we got to remember, absolute value is the v. Quadratic equation is a parabola, okay? And then obviously a linear equation is simply a line. Okay, so we're all going to find a starting point. So I'll do the starting points, let's say in green here. So here the starting point is 2, negative 3. And again, we take the opposite here and the number out here. So, a lot of times referred to as h, k. Okay, so we're going to start at 2, negative 3. And there's our point. Now, we look at this value right here, which is the 2. And that is our slope of the line. And since we're talking about a v with straight lines, I'm simply going to go up 2 over 1. Up 2 over 1, and it's positive, so it's going up. So I can start to see this side of the v, and we just do the same to the other side. Up 2 over 1 on this side, same slope of 2, just a mirror image of it on the left side. Okay. Now, notice we're going to do the exact same thing for parabola. We still have a starting point of 2, negative 3. Okay. So we're going to go over to 2, negative 3. And the only thing that's different is the type of function. So instead of being a v, it's now a parabola. So we just draw in the parabola. So really you don't have to know a whole lot different about graphing. You just have to know how to relate it and how to start. So we're simply going to do a stepping pattern of 2, which is 1, 3, 5. And then we're going to multiply it by 2 all the way down and get 2, 6, 10. Okay? So we're going to go up 1, over 1, up 2, over 1, up 6. And do the same. So maybe let's go ahead and dash in our axis of symmetry, and it's a good point, so I'll write that down. So that's going to be x is equal to 2, goes through the vertex, and we'll do the same stepping pattern on this side. And once we see that, we can connect the dots, and notice it's a nice gentle curve through there, okay, not the hard V like we see over there. Okay. Now, watch how this works here. Here's point slope form. So if you look at point slope, we have a starting point of 2, and then this is really y minus negative 3. Okay. Now I'm going to show you how we make this look like these. If I subtract 3 from both sides, it looks like this. Y is equal to 2, and then x minus 2 minus 3. And notice it's the exact same thing. It's like vertex form. We have a starting point at -2, comma -3. It's simply x minus 2 to the first power, which is a line. Okay, so we do the same thing. We go over to 2, comma -3. There's my starting point. And then from here, we have a slope of 2. So I get some guidelines, drawing my line. So there we are able to draw 3 separate graphs, but with a starting point and then recognizing what type of graph it is and with either the slope or stepping pattern, and shows us how to draw in the respective graph that belongs, either a line, a parabola, or a V for absolute value. So this is a great slide to kind of combine all the chapters together there. Okay, so let's talk about graphing systems. So here we have multiple equations and we want to graph them. Okay, now notice here, I'm just going to sketch what this looks like. So we have 2x plus 3, do this in blue here. So we're going to start at 3 and we have a line that goes like this. And I'm just going to quickly sketch this in. And let me do a different color here for this one. And this one we have a starting point at 0.4, so obviously you can only really kind of guesstimate. And we have a slope of 1/3, so we go up 1 and over 3, up 1 over 3, and so forth. So we get a line that looks like this. Now obviously we have an intersection right here. So we can't really do it per se on a graphing to be accurate. So I'm going to put it into my calculator. So just to show calculator-wise, what we want to do is we are going to plug it into a calculator. So let's go ahead and turn this on and go to y equals, clear out what we have, and I'm going to type it into equations. So we have 2x plus 3, and the next one is going to be 1/3 x. I always like to use parentheses here, so very clear, minus 0.4. Okay. Now I'm going to go to zoom standard, so it kind of goes back to that standard graph of 10, 10, 10, 10, 10. And there's the first line, and there's the second line. So we can see it. Now again, the calculator gives an accurate thing. So I'm going to go to second, calculate, and I'm going to find the intersection. And again, it's going to ask for the first curve, so notice it's on the first function, yes. It's the second curve, the second function, the shallower line, yes. And it's saying, okay, go ahead and guess and tell the calculator, where to start calculating at. And we can see the Mr. Blinky dot right there at the intersection. Hit enter. And now we can get a more accurate solution here. So we have a point of negative 0.04 and negative 1.08. So negative 2.04 and comma negative 1.08. I believe that was right. Let me pull up the calculator again to confirm. And looks good. Okay, so notice that's how we can use the calculator. And again, we use that for finding the vertexes, zeros, whatever the case is. Now, let's take a look over here, graphing inequalities. So again, we want to graph this line here. So we're going to start at -4. 1, 2, 3, 4. And notice there's no equal to bar, and we have a slope of 2, so I'm going to put a dashed line in. So let me get some guidelines. And I'm going to dash a line in. Okay. And let's do a second line here in red. And this is x is less than or equal to -2. So this is a vertical line. So I'm going to start at -2 here. And solid. Okay. And you know what? I'm going to go back to this green line. And I'm going to extend this a little further so we can see. Okay. Now it's asking us to shade the region where it is. Now you can plug in test points and so forth. But here I'm going to look at it and we're going to see, okay, y is less than this line. Okay, so we have to be on the lower half of that line. And then x has to be less than -2. So we have to be on the back side, the left side of that line. So where do these two intersect? Well, right down here in this bottom corner. And I'm going to shade it in blue here so we can see a little better. So this intersection down here is where the two graphs overlap. Okay, and it's a little bit off the graph there, but we can still see that. And the thing is, the shade doesn't always, contain to this 10 by 10 grid here. It's where it lies. So we need to do test points for each curve and find a common area. All right, so let's take a look here at solving systems. Now, Here we have two equations, and by algebra, by hand, we have, really two solutions. We could graph it like we just showed, or we can do substitution or elimination. So let's go ahead and do elimination. So I wanted to get rid of the y's right here. So to do that, I have to get the y's canceled out. So I'm going to multiply this bottom equation by 2. Okay, so I'm going to rewrite it, and I'll just, do it right here. So the top equation is still the same. So I'm just going to write the top equation as is. And now I'm going to multiply the bottom equation by 2. So now we're going to have 6x plus 4y is equal to 30. Okay, and simply go through here, and we're going to have 11x. Notice those cancel out, and we get 33. Excellent. So now we divide by 11, and x is equal to 3. Okay, good. So now we're going to take this, and then we're going to plug it back into the equation. Okay, so I'll do it in a different color, and I'll plug into the first equation. So we have 5 times 3, minus 4y is equal to 3. So we have negative 4y is equal to 3. Move the 15 over, get negative 12. And y is also equal to 3 on this side too. Okay, so now we have a solution, one solution, which involves a 3 and a 3 for both the x and the y. Okay, now if we want to do it as a matrix, now the nice thing is, a lot of times now that we have the calculator, we can quickly do this. Now, some people would argue a problem like this, you could do it just as quick by hand, but if this was a 3 by 3, 3 equations with 3 variables, matrix want to go. So let's go ahead and set this up using a matrix. So again, I want to set up my matrices. So I'm going to do x and y's, and I do first equation, second equation. So we have 5x's and negative 4y's, and then we have 3x's and 2y's. Now I'm going to do my second matrix, which is the variables. So I'm going to put my x and my y right here, and those are the two variables, x and y. And this is the, the value of it, okay? So let's abbreviate. And then this is equal to the total value of the equations, 1 and 2. And that's the total value right there. So notice the row and columns cancel out, and we have equation values over here. So this is going to be 3 and 15. So this is that whole matrix A times matrix X is equal to matrix B. And once we see this format, we simply do X is the same as inverse of A times B. And we simply plug this into our calculator, and then on our calculator, and I'm not going to go through the whole process here because we know how to do that, but I want to show that we can take this, convert it to a matrix setup, plug this into our calculator, and I simply hit output, and the calculator is going to show a matrix that looks like this, and I'll simply say 3, 3, and there's your x and y value, and we simply just write it as an ordered pair. Okay, so this is a great setup, and this is going to come up quite a bit in any time we have to solve a system. Great to use matrices. So there's two connections right there. Now let's talk about matrices, just kind of break it down a little further. So remember in matrices, let's keep this in green here, I guess. We have row times column. So row times column. And in this case, it's the class, by the gender. Okay. And so here we'd say, okay, there's 10 boys in period 1 and 9 girls in period 1 and 16 and 12 respectively in period 2. Now if I want to add this to another set of data, and let's say another teacher's data, we would do boys and girls, and then first period, second period, and they had 8 boys and then 7 girls in that class, and then 13 boys and 11 girls in the second class. And if I said, okay, if I want to add those together, what we're looking at is corresponding positions. So like 10 and 8 would then form the final answer of 18, which would go here. And notice those are the same spots right there. Okay, so let me go ahead and finish the numbers. So we got 9 and 7, which should be a 16. 16 and 13 which is 29, and then 12 and 11, which is 23. Okay, but notice corresponding positions. Okay, so let's take a look at another example here. So here we have, notice matrix addition. So we're looking at corresponding positions. So if I want to solve for x, here's x. So we're looking for, row 1, column 2, row 1, column 2, row 1, column 2. So from there, I can write an equation. Say, okay, 5x, and I'm looking at the plus, plus 2 is equal to 12. So, oh, that's pretty easy. Then this is write a linear equation from there, and x is equal to 2. And then we can do the same thing for y. So y is this position, first row, first column. And we say, okay, that's simply going to be 4 plus negative 11 is equal to y. Oh, that's easy. And then you say negative 7 is equal to y. So, okay, so then we say, okay, the x and y value here is 2 comma negative 7. Okay, so there's the 2, and there's negative 7. Okay, so notice we can pull specific pieces of data out of matrices as well. All right, let's take a look here at multiplying matrices. Now, the first thing you want to do is list the row times column. So here we have 3 rows by 2 columns, and here we have 2 rows by 2 columns. And what I like to do is right away I'm going to highlight the rows in the first set and the columns in the second set. And I want to look to say, okay, are these two compatible? The rows and the columns have to be the same. They are, so I'm going to eliminate them. And then we have an answer of a 3 by 2. So let's go ahead and do a 3 by 2. So we have 3 rows, 2 columns. And I like to label them so I don't get confused. And let's take a look here. Now, if I want to find this position right here, row 1, column 1, I'm going to look at row 1, column 1. Now I'm just going to go through this first piece here. Let's do it in blue. So I'm going to take first entry, 4 times negative 3 is negative 12. Second entry, 3 times 1 is 3. And again, we are adding these two elements together. So negative 12 plus 3 is equal to negative 9. And negative 9 goes there. Okay, and we do that for all the positions there. Okay, so again, I'll just kind of leave it like that so we can kind of focus on one entry. But then this one has to be row 1, column 2. Row 1, column 2, and you'd fill in all the respective pieces. Okay, let's go ahead and take a look at this example. Now, notice here, before I get my rows and columns, I want to see if things are compatible. So here I have 3 rows, 2 columns, then 3 rows and 3 columns. But right away, I can see that those two are not compatible. So I'm just going to say not possible. Okay, because they don't match. So you can't do it. Okay, so that's the first thing you want to look for in situations like that. All right, the last thing I want to point out here, we've gone through a lot of information here, is, and we saw it a little bit early on, is imaginary numbers. And this was a big topic here in the first quarter is, what do I do with imaginary numbers? So imaginary numbers is right here. When you get the square root of negative 1, can't do it in the real world, so we understand it to be I. Now we have to look here. Well, if you just have one I, you just get I. I squared is, well, what's the square root of negative 1? Squared, you get negative 1. I cubed is I times I squared, so what's I times negative 1? Negative I. And I, likewise, what's I to the 4th? Well, that's I squared, so what's negative 1 squared? Positive 1. And then once you get to like I to the 5th, it just starts back over again. And every set of 4, it just repeats itself. So when I look at I to the 10th, this is really I to the 4th, okay, which is 1. And you do it 2 times, so that's 8 of them. And you got 2 i's left over. So I'm looking at for how many groups of 4 can I have, because this equivalent is 1. So it disappears. And we look at I squared and never want to leave exponent I. So what's I squared? It's right here. And the answer to this is negative 1. Okay. Now, so let's take a look here. How does it apply to like a solving problem? Well, square root, do our plus minus there. So we have x is equal to plus or minus the square root of negative 24. Now again, we want to take that out. So we have I, and then we want to break down this into the square root of 4 and the square root of 6. Now again, how do we want to write this so it looks proper? Put the plus minus first. The square root of 4 is simply 2. Then you put the I, and then you put the radical at the end. So that's the best way to show that. Okay. All right, take a look at this next example here. How do we combine complex numbers? Notice A plus BI forms. Let's put a little note over here. A plus BI form is a key thing to know as well. So I'm going to add like terms. So 3 minus 4 is negative 1. And then we're going to do negative 2i minus 3i, which is negative 5i. And there is our a plus bi form. Okay, this last step right over here, I'm going to go show how to do the conjugate. So again, we cannot have an I in the denominator. So I'm going to do 4 minus 3i, and then 4 minus 3i, both top and bottom. And I'm going to double distribute through. Some of us like to call it foiling. So let's see what that looks like. So the top is going to be 3 times 4 is 12. And then 3 and negative 3i is negative 9i. Then we have negative 8i. And then we have positive 6i squared. Let's do the bottom. Now notice here we're going to have the middle terms drop out, and that's the whole key. 4 times 4 is 16. And I'll go ahead and write it out. So we have 4 times negative 3 is negative 12i. Then right behind it we have positive 12i, because notice we have the 3i and the 4 there is positive. So those cancel out. And then we have the 3i, and then so that becomes negative 9i squared. So the nice thing is those two middle things drop out. So let's go ahead and clean this up a little bit. On top here, the thing I want to point out is when we see this I squared, well, I guess it didn't show up there, negative 6i squared, this becomes negative 1. Likewise with this down here, that becomes negative 1. So really we have, what's negative 1 times positive 6? Negative 6. So 12 minus 6 is simply 6. And then we combine like terms right here and get negative 17i. So there's the top. So we're in a plus bi form. And the bottom here, the middle terms, they cancel out. So then we have 16 minus 9, which is times by negative 1. So that's positive 9. 16 plus 9 is 25. So notice we have no more i's on the bottom, and that's how we want to leave our answer. So just like that right there. Okay. All right. So again, this video, I know it's a lot of information here, but we've gone a lot here the last so many weeks, and it's a good way to kind of look as a composite whole where we're at right now.